Good day, everyone. I would like to thank DOST PCIEERD unang-una for making us one of its grantees under the FLAG program, and second, for giving me the opportunity to be part of this year's ball and allowing me na may share sa inyo itong aming project entitled Design of a 3D printed polymer-based adsorbent containing in-situ grown waste but plastics-derived metal organic framework for effective removal of textile dye from polluted water. Hi, I am Lawrence Portillo, the proud leader of this project, ABS Chemical Engineering student from Batch to the NEO Langilad under the mentorship of Dr. Yomark Malihan. To start, sa context ng wastewater treatment, lalo na yung contaminated ng dye o colored organic pollutants na commonly dumped by textile industry, various treatment techniques are being employed para maalis ang mga ito bago sila safely withdraw sa environment. Isa sa mga emerging materials ngayon that is trying to level up the game na hindi ma-offer ng traditional activated carbon, zeolite, and etc. ay yung tinatawag na MOF o Metal Organic Framework. So they are in powdered form and it piques interest pagdating sa water treatment dahil sa excellent adsorption capacity nito. However, since powder nga siya, yung ease of handling nito, compactness, mechanical stability, at yung design flexibility ay mabababa. Our solution, make MOF grow on a 3D printed structure. The idea was to integrate MOF with another emerging field pagdating sa larangan ng material science, ang 3D printing o additive manufacturing. Kung sa ganun, yung attributes ni powdered na low ay may improve niya, further maximizing its power pagdating sa dye removal. Paano namin siya ginawa? So this is the methodology of the project. First is the 3D printing of the polymer structure kung saan mag-grow si MOF. And then production of terephthalic acid cross-linker from waste plastic bottles. So si terephthalic acid cross-linker is the organic part dun sa metal organic framework and we derived it sa waste PET bottles. Next is the synthesis of the adsorbent via in-situ growth or series of chemical process na kung saan ang process ay sinasubmerge lang siya sa iba't ibang solutions. And then next is the batch removal of methyl orange dye sa isang laboratory setup and then investigating its reusability capacity or yung ability niya na magamit ng paulit-ulit while maintaining its capacity na makapag-remove ng dye. And then finally, its optimization using response surface methodology. We were able to gather great results as you can see from the slide. Naging visible yung color change ng dye from white to yellowish or to even orange as the color of the dye. And then yung paglinaw ng MO solution as the time progresses or as the time progressed. Then next, para malaman kung saan conditions magkakaroon ng pinakamataas na amount ng na-remove na dye, may 5 factors kami na pinag-aralan such as infill density, number of coating cycles, pH, contact time, and initial dye concentration. And it was found out na optimum conditions ay 55%, 4, 4, 60 minutes, and 10 parts per million. We also investigated yung kakayahan ng 3D printed adsorbent na magamit ng paulit-ulit while maintaining its removal capacity, and it was able to reach hanggang 5 reuses and was able to see visible results pagdating sa color change ng dye solution at ng mismong adsorbent. Here are the optical microscopy and SEM images before and after ng dye removal to further prove yung naging ability ng 3D printed adsorbent. And nung kinumpara ang adsorption capacity ng 3D printed adsorbent sa ibang existing na material, it was found out na mas mataas ang adsorption capacity nito as reflected sa table. With all this, it is believed na ang project nito ay magiging impactful both socially and economically. Plastic bottles na annually palaki ng naging contribution sa water pollution will have another recycling path. Pwede pala siyang i-subject sa ilang simpleng chemical procedures lang para maging organic part dun sa metal organic framework. Also, sa field ng 3D printing, this project will for sure spark more ideas both in academia and industrial centers. Economically, the production cost for this project was relatively low compared sa ibang materials of the same amount or volume sa market. The future outlook includes syempre yung paggamit niya sa malalaking industries as mentioned earlier, and with the promising findings na nakalap ng studying ito, we're optimistic that this can be a milestone pagdating sa science and innovation or even sa engineering. That would be all for my presentation for today. Thank you for listening.